1.6.1, we're looking at polynomial inequalities. So I have a 6-step procedure here from your textbook, and we're going to just walk through some examples using that process. So step 1, we're going to write the inequality in standard form. So we're looking at quadratics or polynomials. So standard form, we want all the values on the left. So we have 0 on the right side, and we have it in descending order. So in standard form, this one would look like 6t squared, and then I want to move the t to the other side, so I subtract t from both sides and get this. So now it's in standard form, so that's my step 1. Now for step 2, let's do step 2 in green. Now we're going to identify the 0. So to do that, I have to set it equal to 0. So I'm actually going to change that inequality sign to an equal sign so I can solve and find out the zeros. So to solve a quadratic for zeros, I need to factor it. Actually, this one doesn't factor that easily because of the 6 in front. So I need to do a couple more steps. So 7 times 6 is negative 42, and I have a negative 1 in front of the t, so thinking of what factors of negative 42, it's negative, so I have a difference of 1. So let's see, that's 6 and 7. And since I have a difference of negative 1, I want the negative on the 7. So I rewrite this as 6t squared minus 7t plus 6t minus 7. So I'm replacing that negative t with minus 7 plus 6. And then I can factor this by taking the GCF and grouping. So that means I take the GCF out of the first two terms and I get t out, and I get 6t minus 7. And then I can take the well, there's no GCF for the second two terms, but that's okay because I get a 6t minus 7 in both parentheses, so I have my understood 1 right there. So I factor out that common factor of 6t minus 7, and I have left t plus 1. That equals 0, so my two zeros are the 0 that corresponds with the t plus 1 is t equal negative 1, and the 0 that corresponds with the 6t minus 7 is t equal to 7, 6. So those are my two zeros. So that was step 2. Now for step 3, I'm going to draw a number line, and I'm going to use those zeros to make intervals. So remember that the polynomial can change signs only at a 0. It's either all above or all below unless it crosses the x-axis. So I'm going to use a number line and put my zeros in order on my number line. So negative 1 comes first, and then the 7, 6. That's 1 and 1, 6. And then I have 3 intervals there. One left of negative 1, between negative 1 and 7, 6, and one to the right of 7, 6. So that is step 3. And then step 4, I'm going to determine the sign of the polynomial in each of these intervals. Remember, it can only change signs at the 0. So we're going to do some test values. So to the left of negative 1, we can test negative 2, sorry. And I get, so plugging that negative 2 into, I'm going to use this factored form to plug things in. And that's the easiest way to do it. And I don't really care what the value is if I plug in negative 2. I just care if it's positive or negative. So I have two factors here. And I'm just going to find the sign of each of those factors and what happens when I multiply them together. So when I plug in a negative 2 into the 6t minus 7, plug in a negative 2, so I got 6 times negative 2 gives me negative 12, minus 7 gives me a negative. And then plug in a negative 2 into t plus 1, so that's negative 2 plus 1 gives me another negative. So I have a positive in this interval. Okay, and then my next interval between negative 1 and 7, 6, I can test a 0. So plugging in 0 for 6t minus 7, plugging in 0 for t, I get negative 7, which is a negative. And t plus 1 is going to give me a positive. So that means in this interval, everything is negative. And then on the right, I could test 2. And then I have plugging in 2 for t, and 6 times 2 is 12, minus 7, that's a positive. And 6 plus 1, that gives me a positive. So on the right side, I have all positives. So I did step 4. All right, moving on to step 5. Identify which interval makes the inequality true. Okay, so my inequality, and going back to step 1 here, is a less than or equal, which means I want to know when the value is going to be negative, because it's less than or equal to 0. So if I'm looking at my study tip now. If the polynomial is less than 0, then the intervals that yield a negative product should be selected. If the original polynomial is greater than 0, then the intervals that yield the positive product should be selected. Okay, well, I have a negative less than 0, and so I'm looking for the negative intervals. So I just have that one right there. So that's my step 5. And then in step 6, I want to write that solution in interval notation. So we're going from negative 1 to 7, 6 is the only negative interval. And because it's a less than or equal sign, there's an equal right there. So I'm going to include the negative 1 and the 7, 6. So my interval that this is true on is a negative 1 to 7, 6. So remember, to solve a inequality, I'm looking for all the places or the interval that it's true. So it's true on the interval of negative 1 to 7, 6 inclusive. So that's my answer for that one. So let's try another example. All right. So again, step 1 is, let's try to be consistent with colors here. For step 1, I want to write it in standard form, which means get everything, all the zeros on one side and everything else on the left. So, or on the other side. So I have an x squared first, and then I need to subtract 15 from both sides. So I end up getting negative 16 on the left, and on the right I have 0. So that's my standard form. Now I need to identify the zeros of that. So I can factor the left side. I get x minus 4, x plus 4, which is greater than or equal to 0. So I'm factoring to get the zeros. Notice you cannot use the square root method on inequalities because that uses the property of equality, but these aren't equal. I'm actually going to set these actually equal so I can use that factoring to find the zeros. So zeros means when does it equal 0? So that corresponds to the zeros of x equals 4 and x equals negative 4. So those are my two zeros. And the next thing I need to do is draw my number line. So on my number line, I'm using my zeros to make my intervals. So I have a negative 4 and a 4, putting those in order from least to greatest. and I'm going to test on each side of the interval. So my first interval, I could test -5, for example. So I'm going to plug that into that factored form. So when I plug -5 into this factored form, I get -5 minus 4. I know that's going to be negative. And then plugging in -5 into the next one, the x plus 4, I get another negative. So I know this whole interval is going to be negative. I'm sorry, negative times a negative is positive. And then my next interval, I could test something between -4 and 4. So I'm going to test 0. 0 is always a favorite. And then I have when I plug in the x, the 0 for these x's, I get negative times a positive, which gives me a negative for that whole interval. And then in the last interval, I'm going to test a 5. And when I test a 5, I get 5 minus 4 is a positive, and 5 plus 4 is a positive, so I get positive for this interval. And then on step 5, so I have a greater than or equal to sign. So when the original polynomial is greater than 0, then I'm looking for all the positive products. So the intervals that have a positive. So this one and this one. So to write that in interval notation, I'm going to, I have two intervals here. I have from -infinity up to -4. And there is an equal sign here, so that means I'm going to include the -4. And skip that center interval because it's not true there. And then union, and I'm going to include the 4 because, again, it's inclusive with that equal sign. So these are going to be included up to infinity. And I don't include infinity because we never reach infinity. And that's my final answer for this example. And let's do one more example. So in this last example, for step 1, I want to write it in standard form, getting those 0 on the other side. So I'll go u squared, and then to get it in standard form, I'll subtract 7u from both sides. And then I want to find the zeros, so I'm actually going to set this equal to 0. So that's finding my zeros. And then factor. So I find u equals 0 or u equals 7. Those are my x-intercepts or my zeros. And then I'm going to draw my number line with those zeros as to make the intervals. So I have 0 and 7. So I have 3 intervals made by those 2 zeros. And then I have, to determine the sign, I'm going to use the factored form. So right here, I am going to plug in a 0 into here. Oh, and actually, I'm going to plug in test values in the intervals. So let's test a -1. So if I plug in a -1, u is negative, of course, and then u minus 7 will also be negative. So when I multiply those together, I get a positive. And then in between 0 and 7, we could test +1, and I get a positive for u, and 1 minus 7 is a negative. So that's going to give me a negative in that whole interval. And then my third interval, I test, let's test a 10. We could do 8. 10's nice and round. I'm going to do 10. So then I get a positive. U is 10 is positive, and then 10 minus 7 is also positive. So I get a positive in this whole interval. All right, and that brings me, that was step 4. That brings me to step 5. which says that if this is a less than sign, then I'm looking for when the interval yields a negative product. So that's just that center interval right there. And I want to express that interval in interval notation for step 6. And that goes from 0 to 7. And because it's a strict less than sign, there's no equal sign. That means I have open parentheses as my final answer. So an important thing to notice about quadratics is that when solving quadratic inequalities, you must first write the inequality in standard form and then factor to identify the zeros.